So here it says in the diagram OAXP is the sector of a circle of center O. This OAXB is the sector of a circle of center O. Alright. And radius is 10 centimeter. OB is 10 centimeter, hence OA will also be 10 centimeter. Right, because of the radius. And hence OX will also be 10 centimeter. Alright. The length of the chord AB is 12 centimeter. The line OX passes through M, and M is the midpoint of AB. So AB is 12, hence AM will be 6 and MB will be 6. Alright, centimeters. OX is perpendicular to AB. OX is perpendicular to AB. Alright, there's a 90-degree angle shown. The shaded region is bounded by the chord AB and by the arc of a circle with center X and radius XA. So this AB is basically the arc of a circle which has its center at X, and hence its radius is XA and XB, and this is the arc of the circle with center at X, right? And the arc AB is the arc of a circle with center at O, right? So this arc is starting from center O. Alright, now it says show that the angle AXB is 4.98 radian. They're asking us to find this angle AXB, right, is 2.498 radian. Alright, so how we'll do that? Let's plan. If I take the triangle AXM and I find the angle AXM and I multiply this angle AXM by 2, I'll get the angle AXB, because this is an isosceles triangle. AX equals XB. Hence this line, which is going directly to the base, cutting the base into two equal halves, will also be the angle bisector of this angle, which will divide this angle into two equal halves. So if I find the angle AXM and multiply it by 2, I'll get the angle AXB. And I can find the angle AXM from the triangle AXM, right? So let me draw the triangle AXM. Part 1. The triangle AXM is like this. This is A, X, M. We know this is 6, right? This is 90 degrees. And we don't know this side. And we don't know AX2, right? So basically, it's like this. This is the shape. It's the shape of a kite, right? This is 10. This is 10. And this OX is also 10. Right? Now if I find OM, I can find MX, right? Which you need to find this angle. So from triangle AXM, if I do tan of AXM, I'll get 6 over MX. I need to find MX. So MX is OX minus OM. We know OX is 12. OX is 10, sorry. OX is 10. And we need to find OM. We don't know what is OM, right? We can find OM from this triangle AOM. So from triangle AOM, this is our one-sided triangle, this is the hypotenuse of the triangle, this is the third-sided triangle. So 10 squared equals to 6 squared plus OM squared. So if we compute this, we'll get OM equals to 8, right? Hence MX will be 10 minus 8. MX is 2, right? Now I'll put this 2 right here in this mx equals 2 to find angle AXM. So tan AXM equals to 6 by 2. Make sure to put your calculator in the radian mode because they are asking us to find the angle radians. So AXM will be tan inverse of 6 by 2, which is 1.249. And we know that AXP is twice that of, angle AXP is twice that of AXM. AXM is 1.249. If I multiply 2 into 1.249, we get 2.498 radians. Right? So we have proven that angle AXP is 2.498 radians. Now moving on to the second part, which asks us to find the perimeter of region. Now I've told you before, perimeter is basically the sum of all sides. So they have asked us to find the perimeter of shaded region. Now let's plan that out. How to do it? Perimeter of shaded region. Now shaded region is composed of the line AB and the arc AB. And arc AB has a center at X, right? So we can find the arc length of AB by the formula R times theta. R will be the radius of the arc, which is AX, and theta will be this angle at the center of the arc, right? Once you find this length, this arc length AB, will simply add 12 in it, which is the length of the line AB, to find the perimeter of shaded region. Now first of all, we'll find the arc length AB. This is part 2. So now perimeter, sum of all sides, right? So in this case, that is arc length AB plus line AB. Now arc length AB is R times theta, radius times the angle between the arc. R is XA times theta. Theta, we know that we found theta in the previous part, which is 2.498 radians. 2.498 radians. We don't know XA. Now, XA is this side. This one, XA. Now, if we draw the triangle XAM, triangle XAM, this is 6, this is 2, we found this in the previous part. We need to find this XA, which is actually the radius R of the arc. So from this, I can find R equals to 6 squared plus 2 squared. So R is, let me compute this, 6.324. So our arc length becomes 6.324 into 2.498, 15.798, right? So perimeter is arc length AB plus line AB. Arc length is 15.798. The length of the line is 12. So we'll get 27.8 centimeters. Alright. Now moving on to the third part, which is to find the area of the shaded region. Right now, let's plan this out. To find the area of the shaded region, I'll need to find the area of this sector AXB, this entire sector, with center at O, and then I'll subtract that area of the sector AXB with the area of the triangle AXB. Alright, let's write this down. Let's make an expression. So, third part, area of shaded region is area of sector AXB, the bracket form area of triangle AXB, right? So this is area of sector AXB is half r square theta, and area of triangle AXB, I'll use the formula half into side 1 of the triangle into side 2 of the triangle into sine of the angle between them, right? So we know that the area of the sector is half r square theta, and r was AX, and we find AX in the previous part. It is 6.324, right, which is the radius. 6.324 squared times theta is, it was 2.498 minus half times side 1 side 2. Side 1 is 6.324, radius and 6.324 again, side 2 into sine the angle between them, sine of 2.498. If we compute this, we'll get 7.952 or 38 centimeter squared area of the shaded region.